Okay, and we're live. Welcome back to the stream. I'm Jun Chen, and today we're working on our Purescript implementation of the Chronofold data structure. And we did quite a bit of progress last time. We sort of finally went out of the phase of trying to understand the paper and started to move towards a naive implementation. Well, naive, but still with quite a bit of the what's in the paper called the co-structures, which are really meant for efficiency. But I think my implementation of some of these co-structures is naive at this point. I haven't given too much thought about them yet. Also, keep in mind this is my first time implementing a data structure, even though I've seen people do it, like Edward Kmet, for instance, in Haskell, but definitely also my first time in Purescript. So yeah, that being said, last time when we left, we had some runtime error, which is one that we actually we're throwing ourselves in our implementation in case we were receiving a timestamp that already existed in our ref data structure. I think, yeah, exists in ref. We have also an NDX data structure. And let's see, do I have my chat? I think I don't have my chat notification up and running, so let's do that. And then maybe also put a bit of sound. Okay, and I think I am connected. Very good. All right. So let's look a little bit in more detail. As I was modifying, let's try and follow the control flow and what happens with refs. So as I append an ob, I'm supposed to add refs, and this is when I think I had things indexed or offset in how I was passing my ref. And I think it's probably about how I'm passing the ref with my append string implementation. So let's try and basically trigger the same bug, but doing it manually. And I think we can do that by doing a op for alpha, which is going to basically pass what? For the ref to already exist, I think it just needs to pass another alpha 2, right? Is that right? Let's see if this triggers the exception or not. And I think usually you don't want to throw exception, which is why these things are called unsafe, right? But inside the belly of a data structure in which you want invariance to be maintained, it might be okay, but in our case, it's probably not okay because we don't want to allow people to crash the data structure by sending the wrong op. But that depends on the invariance in the rest of our program. So for now, this is good. We're still troubleshooting. And yeah, I want to then print that alpha log 4 and run that. So that's fine. I have a 3 character in my thinned chronofold. My next Let's bring back the type of things here. My next array seems to be dandy. My NDX array says that character alpha 2 is at index 0, which is right. Character alpha 3 is at index 1. Character alpha 4 is at, or timestamp alpha 4 is at index 2. That's all good. And we added the replica index. Forgot about that. Replica index is here, right? That's the current index in the data structure. So I actually need to update that. Next, and then the next inverse is that we have alpha 2 in position 1, alpha 3 in position 2, or alpha 2 in position 0, alpha 3 in position 1, alpha 4 in position 2. So that's one of the things that I'm calling naive. This way to index back and forth into the data structure with a map and an array. I'm sure there's a better way to do this. But for now, let's proceed. The last thing we have is a ref. And a ref is a map from a timestamp to a timestamp. Alpha 1 points to nothing, alpha 2 points to alpha 1, alpha 3 points to alpha 2, and alpha 4 points to alpha 2, which we're fine with. And so the problem only arises if, I guess, we're trying to commit alpha 3 twice. And to make sure, let's point toward, well, we can't really point towards an alpha that doesn't exist. But let's try that, actually. Let's try it. I'm not even sure. I don't remember whether I covered this case or not. So timestamps already exist in the ref. So that seems to be our problem here. But but I wasn't expecting this I wasn't expecting this to show up in the ref, to be honest. And if I do alpha 2 here, where we have same error, right? Okay, so let's check. We check if t, which is the timestamp of the op, which is alpha 3 in our case, is a member already of our ref data structure. Yeah, so that's correct. So it's a duplicate key in the in ref, and we can't have that. So we definitely need to bail out. So that's all good. And so it turns out that then when we run our append string, then we do this when we shouldn't. And so let's check again. Right, there was some we were folding with index, and fold with index takes a build up for us that takes the index, the current index that we're looking at. Okay, right. It's taking the current index that we're looking at, and yeah, that's wrong. We should be, I think. So we want to update the log each time we pass, each time we advance our index, but it's not I+1, that's wrong. It's just I+j here as well. And here I think needs to be I+j. And here would be I+j -1, but let's try it out. Already exists. Let's I think we can use a debug trace somewhere to clarify what's up here. So let's do that. Debug trace, right? Yeah. Debug.trace or spy, right? There's a spy. So import debug trace. And we don't have it because it's in the debug package. Spago install debug. Hey Chris, what's up? Yeah, it's about 5 or so. It's good to see you, man. I am hey, thanks. Yeah, I'm really happy about it. Yeah, really happy about it. I had a really good chat with quite a bit of the member of the team and really enjoyed it. And yeah, and then I started streaming as well, right? That's a fun thing. Yeah, me too, man. Me too. Absolutely miss that a lot. And you know, I've been watching your. Today I was rewatching your Monadic Warsaw Comonad talks, and really enjoying the. I think I started. I've got a little bit more Comonad thinking under my belt now, and I appreciate the new abstractions that you brought in to explain things like the view and the query and mutation. That's really cool. And yeah, there's actually since then I bumped into this idea of the zap in Haskell and the pair in Purescript. This idea that you can interpret a free monadic DSL with a co-free interpreter that you can build up from stuff, and it's just some beautiful stuff. Right, yeah, that stuff is magic, man. It's so awesome, and it's Phil Freeman has done this. Well, he does this thing on comonadic UIs, right? And some of the how the meat of that. Actually, someone wrote a thesis on top of it, and yeah, it's the React Explorer, I think is how it's called, tab 31. Phil talks about it in his blog post, explaining that he calls it pair or pairing, but that it's actually in the adjunctions package, and that command was there first, as always. And there's some really fun stuff around that, so he's in his React implementation. Right, he also uses the functor, like getting a monad from any comonad. Oh, cool. That's nice. That's super nice. Yeah. So, and there's something I haven't yet understood is whether if you have a free monad, you can get a co-free comonad, and that you it. You obviously get the monad, right? But do you get the paired functor? And I think you do, right? I think you see like co-free of F is isomorphic to free G, where G is the free monad. That's the pair of the co-free comonad. So not only you have the monad and the comonad, but also you have F and G pairing, And that stuff is just pretty mind-blowing, because it means that you can, you know, build a free monad from products and then a comonadic interpreter from coproducts. And so everything becomes somehow modular. That stuff is pretty amazing. Yeah. Yeah, so that's, I've been thinking about that, and thinking about it also in relation to this really cool library in the Purescript ecosystem, which is actually a bit like a machines or pipes, right? Like, I mean, it's an implementation of machine or pipes, and it uses this extensible effects framework in Purescript called Run, where you can basically specify your effects in an extensible record, you know, as Purescript has these days. Purescript Run. Right, so it's a kind of a way to add effects on top of each other with a row, and so it's like MTL but with extensible effects, right? Hey, thanks. Today I'm working on the Chronofold data structure. It's a CRDT, but it's and I'm trying to. I spent a while reading the paper, and I'm now trying to do an implementation in Purescript of that. And it's a CRDT that's specifically optimized for text editors. So a bit like, you know, like Xi had its rope and whatnot, and it turns out that VS Code uses a kind of a piece table on top of some kind of balance tree. And this data structure is meant to be basically, it is really optimized to be both a real-time syncable data structure in the CRDT paradigm, but also efficient for text editing specifically. So taking some stuff from the book of doing fast data structure for text. Yeah, exactly. Because it's conflict-free, you actually turn out to basically sort of have always, a merge is always doable in such a way that all replica converge. And so, like, one of the examples of that is that, you know, you have a CMD in replica 1 and CMD del in replica 2 and CMD alt in replica 3, and then when site 1 starts deleting MD and adding TRL, then you get actually the control alt del in every replica. And so it's something about, you know, having allowing each site to have a partial order of the characters they add to their own log, and then having a sort of inferring a global order by ordering the sites, basically, and keeping track of what was it that site 2 saw from site 1 when it started writing DEL, and that sort of what that concept of what site 2 saw is what could be called the causality. The causal tree is linked to that. So the Chronofold author, Viktor Grishenko, had done a couple of talks that are on YouTube explaining that, and then there's his paper. So I've been working from that, and yeah, right now I'm actually, you know, I've done a first sort of naive implementation of the different data structure that he recommends using. There's just an array of code point, and then there's an index, because one of the key things is that there's the log index, which is what each replica has that's indexed with like in a regular array, and then there's these sort of timestamps there, which have a replica and an order, and these get shifted around, and so it's almost like the top numbers in the local index are like local time coordinates, so to speak, or local coordinates, and the alpha blah are shared coordinates. And then each replica can end up with things that are in a different order depending on the order in which they receive stuff from the other replica, but you're able to always resolve it. Even if it's received in a different order, you're always able to resolve it to the same text on all replicas. So you need to keep track of a few dependency, like where is your character written after. Oh, by the way, there's some comonadic stuff that I want to play with afterwards. That's one of the thoughts, is whether there can be a neat comonadic API for that stuff, because the whole cursor aspect to me says comonad. And so the backspace here happens after the P, so it means that the P gets deleted, and then the M happens after the backspace, so it means that it's replaced by an M, and so you get the Minsk thing. But also you keep track of this in the next array, and there's all kind of optimization he proposes, because most of the time, next is going to be the actual next index. So we can store that in a sparse array, and then we need to a mapping, a local mapping of local indices to global coordinates, so to speak, or timestamps, and vice versa. So that's ndx and ndx-inv. And then there's the ref, which is the causal ref, and so together next and ref sort of, they kind of make this doubly linked list, and then there's an algorithm for when there's a conflict, and the conflict means that basically you're adding two strings that have the same ref. They point to the same parent, or what can be called a causal parent. So he draws this here. So if several things are actually are hanging from M in the causal tree, then you have a merge resolution algorithm that's here. And I haven't started on that yet. I was just right now fixing a bug on how to add operations properly to the log. Oh yeah, absolutely. There's a Rust implementation, and which apparently doesn't use all of the proposed optimizations that are in the paper by Dominic Kellner. I suspect that maybe the author has a C++ implementation, but it's not yet published. And on top, it's the same author that did RON, the replicated object notation, and he's still working on that. And that's kind of a composable CRDT framework, so to speak. And there's been a lot of work happening but not in the open yet. And so one of the initial implementation of RON was actually in Haskell. And I think it's still maintained, RON package, by someone else, and it's used in this FF notes tool that uses this for a note-taking application, distributed note-taker in Task Manager. Well, some of it is new because the paper is actually 2020, so yeah, April 2020. And but Ron has been around for 2012, I think. He talks about the history here, and so it's based on this CRDT called RGA in the literature, called a replicable growable array. So it's for ordered collection. And 2012 JavaScript implementation of so that was the thing called SwarmDB. So in the runtime there were quite a bit of code around this aspect. And right now I haven't completely understood how you could, for instance, compose a Chronofold with a run data type. but it's a slightly, yeah, I'm not sure exactly. Most of these, because RDTs actually have several semantics from a distributed data type standpoint, right? So RGA is causal trees, and that's for ordered collections. You have the OR set CRDT, that's for unordered collection. And then for products, you can use last win right per field for products. So that is not the full, it doesn't give you a complete way to express necessarily any algebraic data types. But one of the things that I was thinking, actually, you attracted my attention to higher kinded data types. And I've seen that now I've spent more time looking at it, and they can be used to basically annotate any algebraic data type. You can think of it as an annotation layer, and in fact, then you see that a lot of the database stuff. Well, I guess I've been reading a lot. If we had met. Yeah, right. Well, for so many things, right? I think you were showing me first the example for validation, right? But in fact, when you look at how stuff like, what is it, the Beam library for SQL queries, that's just a high kindly data type that annotates, your types, so that how you give them exactly the extra information that you wouldn't have in the raw data type, but that then allows you to properly, deal with them as types in the database. That wouldn't be a good example. I think a manual maybe can show this better. Hey, thanks for the follow, Last Mars. Appreciate it. Yeah, so the schema management is in. Oh, well, I totally want to use this. I haven't started using this yet. Yeah, I think it should be in models. Yeah, model, you derive generic, and then here, yeah, columnar F. So it's a kind of a transformer, right? You keep your slot for the annotation in your higher kindly data type, and then you say columnar, and then you put like a row type or something, and right, sounds like, looks familiar, right? That kind of annotation data type. So I was thinking, the reason why I'm talking about that is I was thinking that probably you could do something similar to kind of start with a model. It could even be flat, right? Because you can actually derive an HKD from a flat ADT. Oh, super cool. Yeah, so how you can derive with a generic instance, right? You can fairly easily slot an F in before all your products, and then you can get and like Higgledy does, right? You showed me that, and so yeah, Beam is pretty cool. And then imagine then that you have a model like that, but instead of decorating it or annotating it with stuff of how it's going to behave in your database, then you annotate it with what its semantics are from a CRDT standpoint. That's kind of what I've been thinking about. But right now I decided to focus on the Purescript stuff and the Chronofold implementation specifically, because it seems like actually totally want to have this data structure and use it actually for something in the stream. I've been trying to log some of the stuff that I'm doing, and imagine this log during the stream was actually a Chronofold, and that people following the stream could just open that stuff. I mean, I know it can be done with VS Code plugins, and there's tons of other ways, right? It could even be in a Google Doc, but just streaming the CRDT, that would be a fun thing. That would be like 2021, right? Okay. So hey, I have a question for you. Maybe you know something. Hey, thanks. So I'm doing this thing that I feel like is really gross. I'm supposed to maintain a mapping between, that's called NDX, from timestamps to the local index, so that when alpha 1 is a timestamp, And it means that on replica alpha at index 1, and then index it's mapped on my local array to, in this case, 1. I write it 1 alpha. But, you know, if I receive, you know, like beta 1 here, it would be like in, say, maybe 7 alpha, right? So we need to do these conversions between this kind of global coordinate system that replica hold and then the way that it's locally present. And in order to make, and we're going to have to do lookups that are reverse of that, ndx minus 1. And so map 1 alpha to alpha 1 as well to see what is in slot 1, and oh, it's timestamp alpha 1. And so in our case, what is in slot 7, it would be beta 1, right? And so right now I've done this as ndx invert because this alpha really, like, you know, it's like basically it's the same as if you had a one indexed array. So I stored this as an array of timestamp, and then lookup is, you know, 01, I believe, right? Because you can just go to the offset and get the timestamp. And then the ndx, because timestamp is this, I'm doing a map out of it. And so I think by doing a map, it would be efficient because that's from an ordered or ordered collections in Purescript, and I think they use a I don't know, I think a red-green tree or something like that, one of the efficient data structures. But I've been wondering, like, is that right? Like, this model? I'm wondering whether that's not a pattern that's more easily available and whether I can, yeah, find something better for this correspondence to store this. But yeah, for now, I don't know. And right, so the other bit is that we're sending these ops over the wire. And so what I've been doing as I move forward, haven't yet gone or reached the some of the crux of the algorithm, really, which is this merge, the conflict resolution thing. Two-way maps, right? Yeah, right. Yeah. So maybe you know, maybe it's just what it is, and it's simple, and there's nothing more to think of. That's cool. He's giving some further optimization in the paper. He says something interesting, like we use the fact that all the, what he calls this co-structures. Yeah, exactly, right. I mean, at some point I'm going to be a little bit paying attention to performance, because that's sort of the idea behind this particular data structure, which is a great exercise for me because I've never really done that. Try to, you know, go deep, especially with now with Purescript as a strict language, and trying to then, you know, make V8 go vroom and all of that stuff. I'm interested in seeing how that can be done in the JavaScript ecosystem. Right, so apart from his the main Chronofold data structure, then he has all of these co-structures. Some of them can be used, for instance, like range maps, to do something that I used to think of in Rasa, which is basically interval maps of some sort to store things like formatting and whatnot. And so he thought about that, about how you can also not only ensure that you store that metadata, but also that it's efficiently, you can do something that I've seen the VS Code people talk about in some of their performance talks, which is that you can do something like, do a first pass where you write all the text and it's fast, and then a second pass where you actually this time read the range map with the syntax highlight annotations, and then put in the syntax highlighting, and that's smart, and it's possible with the data structure that he has. And so yeah, so he mentioned something about the fact that because everything is sort of addressed by the log index, then you can put them in the same container. So I'm not sure exactly how that would work for us, but multiple cursors, yeah. Right. Yeah. So that, I think, is not maybe, well, no, I think you could model a cursor as a co-structure, I think. And that indeed, in that case, it needs to have this key of being able to do the mapping from the local coordinate to the global coordinate. That's how I call it, basically the timestamp to the array. So it could be that an author, let's say in this case, right, alpha 6 is Pinsk, and so we can imagine that its cursor is here, and we can say that it's not said in the structure, but I think with those range maps we could add one, and that is the cursor. And then beta comes in, and actually beta moves its cursor here, and then does the beta 7 delete and delete the p, and then writes m, and then writes m. So at that point you have alpha k's cursor is in alpha 7, and beta's cursor is in alpha 2. I guess you could also say that it's beta 8, so you get a choice. But I think, but there's this linked list thing, the next, which and it's which means that you're tracking which character is the next. So even if it's if you're m, you say you're between beta 8 and alpha 3, and that's good for cursor position. So I think it would work for distributed case if you use this data structure. But yeah, I'm looking forward to get there, and I'm also looking forward to think about this idea of cursor and a comonadic API for them, because I wonder whether it can be. I haven't seen any literature on that, but I think it should be possible to do something like a store comonad, but where your cursor is a range rather than a single position in the data structure. And that feels weird and interesting as a comonad. Yeah, I've been wondering about that, and I think I've had some pieces of code lying around, but oh, you did? Can you get a lawful comonad from that, or do you get into problems with like extracting overlaps or whatnot? I don't know what the problems would be, but yeah, it seemed interesting. Right, but not ranges, right? Okay. So okay. So your cursor was an interval. Yeah. So I think then you get into these things where, yeah, you have to do that. Yeah, ranges. Yeah. And how was that? Was this fairly straightforward? Was it beneficial to have a comonadic API, or is it actually, in fact, easier to reason when you're just thinking of ranges? I guess it all depends on whether you can do like algebraic operation over the ranges, which is the thing that I guess I was trying to think of when I was thinking of contributing to Rasa. Is like these layers of annotation of syntax for ranges and how these combine together. Okay, so that seems like that's because of a versioning capability in your edits, right? Right. So like making like persistent data structure, like using the persistence of the data structure in your advantage to kind of maintain a history of something. But that seems like that's pretty convergent with the ideas in the paper, and I think like when he didn't get so far into like this idea of range, and how exactly he's going to implement that, but I'm really curious because I think that that would be cool. Fixed-point comonad. Oh, right. Yeah. Hey, Fiji, 1, 2, 3, 4, thanks for the follow. Right. Hey, Chris, next time you connect in, we should have you on like a Discord or something. I mean, I haven't set up anything like that, but it'd be fun to chat. Okay, right. So this whole interval thing is fascinating, and I think that because intervals have, you know, sort of a pretty well-defined mathematical structure, then I'm sure we can get like something nice, but I'm not sure. Yeah, totally. Awesome. And thanks for bringing some folks over. Really appreciate it. Okay, so let's try and get. So what did I have here? Oh, I was about to do debug and to trace something, to trace the execution of my append string function, because I was having some, I think, off by 1 errors. I mean, actually, I can get it in a state where I think it doesn't have the off by 1 error, which would allow me to run it. It's compiling debug, right? Unexpected token 0. Oh, did I? Yeah. Build succeeded, and runtime error because there's a timestamp. Yeah, already in ref. So that's, I think, is why I wanted to trace. So I see. Oh, it could be that that comes from my alpha 4 here. So let's call this alpha 4 again, and 3 here. Yeah, right. So yeah, so the indices are all over the place. This should be alpha 10 or something, and yeah, I'm using fold with index to, so I convert this string to an array of code points, a 2 code point array, and then I fold with index over it, and then I pass this build up fold function, which takes the index, j, unpack the log, the current version of the local log, in which I've stored also the, well, that's a store command actually, the current cursor, where, well, that doesn't actually operate like a cursor. That operates like the last index. We use this to know what to increment from. And so that's for replica rep, which would be alpha for us. And for, which is, yeah, the last inserted character in our case before we start doing something to, well, it's empty actually. So it starts at 0 or 1. There's a bit of a messiness with the indices because all of the paper stuff, it has a one based arrays notation, and I'm trying to follow the paper. So yeah, so valve is our code point, and so we append the op, and we have an append op operation here, and we give it, so each time we run this, oh, right. So it was +1. Each time we run this, we increment by +1 the version of the last index in the log, right? We increment last timestamp in the log. So if I say this, am I good? Alpha 11, and right, so how this reads is that these are the these are the code point array, which in the paper he called the thinned chronofold, which is the chronofold in some way decoupled from all of its extra data structure that I use for efficiency. Hey Juan, what's up? Hey, thank man. Break time. You know, I've got some pineapple juice this time and it's lovely, so I'm gonna definitely do that. Oh yeah. Yeah, so you know, let's look at our log, right? Yeah, yesterday evening I actually played with something else, which was streaming tools. And hey, Chris. Oh, yeah, totally. I should. Oh, yeah. Well, that's oh, what is it? There's a JSON. Yeah. I actually contacted Chris via a DM today. Chris is a friend who I used to hang out with when he lived in my town, and we used to do a lot of chatting about programming things. And so what are the instructions there? List of active declarative programming streams. Active contributing streamers should be actively streaming on Twitch. Streaming should be focused on functional logic programming. Focuses mostly on one language, refer to make it bold. Add your stream to streamers.json. All fields are required. Submit a PR with your choices. And the CI will auto-generate with me when it hits master. All fields are required, and that's it. So then it looks like it's actually ordered by alphabetical order. So I would be here. And I am this. And I do Purescript by now. And schedule has been daily at 7 at what? Yeah. The schedule data structure is going to be hard to parse, huh? So, well, UTC, there's mostly UTC around, so what is a CET in UTC? +1, okay. So, where was I? Here. I've been doing 6 p.m. UTC +1, okay. Adding myself, and there we go. Cool. Yeah, I guess it depends on whether I want to de-anonymize my time zone or not, right? Okay, awesome. Thanks for the recommendation, Chris. Appreciate it. And a little bit of stretching. And let's get back to it. So we have our array of cut points, and we have 1, 2, 3, 4, 5, and infinite. So that's the next array. So with this terminator, and then we have the map of timestamps to indices. So alpha2 is actually at index 0, 0. Is that right? No, that's not right. alpha 2 is at index 1. Despite that, because we have an alpha 1, oh, right, it's because I didn't, so my empty log, oh, I didn't add my, alpha 1, which is a specificity of this data structure, which is that it starts with this root item. And so, but here I seem to have forgotten to add this root item into my index. So let's do that. So that would be timestamp rep 0, and the value would be the index, therefore 0. No, not 0, but index 0, because we have a new type. And okay, let's try, but I think I probably still have an off by 1 problem here. Yeah, because my alpha 0 is at 0, that's all good, but my alpha 2, well, first of all, it's called alpha 2, so that's not right. Yeah, but that's because I'm doing 2, 4, 6. That's because my function is not right. So, okay, when I fold, my accumulator is my log. So I'm actually getting the I each time. Do I really need this index? It feels like I do. Yeah, that's why I wanted to trace it. Okay, let's trace it. Let's spy on this thing. For start, yeah, it takes a, so that's our log. And I need to say that it's partial or something. Oh no, that's just a warning. Beautiful. Hey. Okay, we're gonna need to look at this in more detail. Okay, so we start with the timestamp with 1, 1 in it, which corresponds to alpha 1. Alpha is 1 and 1 is 1. So that's all good. And then these empty things, and wow, yeah, that's the internal representation of the, that's some kind of balanced tree for the representation of the map. I guess, but I have a show instance, so maybe I should use that instead. Debug trace. not sure. I mean, I think I've used this before, but now I'm kind of, my eyes are glazing over it when I look at it. I'm receiving a unit, and so I just show it, and then, so I can just pass show. No, can't just pass show. Yeah, I think I need to do something like, oh, that's gonna be ugly, but let's do it for now. Trace and blah, and basically kind of const show or something, right? Oopsie. Yeah, that's it. Oof, ugliness. Yeah, I can't even. Okay, I'll do a let statement here. Let log. Hey, Cubesicle, welcome. Yes, you must. This is our playground. This is the style we like, right? Show. Oopsie. Okay, this is because I use this Unicode generation thing. Okay, show log, right? And like this, and with an in will be better. And we can nest let statements, right? No. Maybe we can't, or maybe we indented wrong. Hey. I saw that super weird. Love it. Okay, log timestamp. Like this, and oh, is it just that my comments wrong? Optics are weird. Oh, weird. I see. No, I don't see. Append up. This thing should be log, but it's not. Because of the indentation? No. You need to be. Yeah, you need to be. And be. Oh, right. Yeah, no, that's totally wrong. And in fact, why am I doing this? I should totally just spy the show log. That's what I should do. Oh boy. Well, no, if I spy the show log, then it's going to return. Then it's going to display my whole the whole mess. So that's still not good. So trace. Some value of computation, and it returns the B. Right, so therefore I don't need the log if I do something like MA. Maybe desirable to show the value first. Yeah, that's what I'd like to do. So maybe if I just trace show log and return const log, then that's it. Well, compiled. Oh. And well, yeah, it does work. Cool. So we start with alpha 1 infinity, alpha 0 at 0, and alpha 1 pointing to nothing. That makes sense. And then at alpha 2 we have this quote point, then we insert the 1, and then now we have alpha 2 pointing to 0, and that's not right. So it means that I need to fix, I think, append op. That is my which array, my that's the next array, so it's the ndx, map, and the ndx map insert t at cursor cur, but it should be at cursor +1 because of offset things. Yeah, you know, I still haven't dug into lenses properly yet. Will happen. I think I get them, but oh, there's this thing. You know, Chris, how the store comonad really feels like there's something about the store comonad that yes, I bought Chris's book. And I read through the part that I already understand, and I haven't yet dug into the part that I don't, and I haven't used them so much either. You know, there's this thing about the store comonad and lenses where it feels like store comonad has something that is very lensy. If you kind of squint at it, you know. As we like to say in this subculture. Okay, yeah, so that's better. Alpha 0 points to 0, alpha 2 points to 1, and alpha 3 points to 2. However, we'll probably want our alpha 0 in our array here, so let's also start with alpha 0 in there. So alpha 0 is timestamp rep 0, and instead of having an empty array, which one is this? This one. And let's be nice with the whole constructors for this. Right here. It's isomorphic to a representable functor with an index. So presumably you could use greats with store. Or just use it with ix if you like. Let me find my my exploration of the topic somewhere. It wouldn't be here. It would be here. Store. Actually, if I search for lens, I'll probably find it better. Yeah, squint. That feels like that's me trying to understand this thing. Oh, co-state. All right, that's a Jupyter notebook. Yeah, by the way, you know that you can set up a Jupyter notebook. It won't work in this machine because this actually works in my other machine, but oh well, I say it doesn't work, but actually it displays, so that's pretty. you can set up a Jupyter notebook in VS Code using their, normally Python oriented thing, but with the iHaskell container that Tweag did, I think, and then you get this. Yeah, you just need to do Docker run. I mean, I'm sure you guys don't use something like VS Code like me, the heathen here, but that's pretty cool. You can actually do Jupyter, code notebook things in VS Code with the pretty interface they built for data scientists. Right. So query, co-state, lensish. Yeah, that's maybe being a little bit exploratory here. In some sense, a store comonad as a queryable data context can have a focus, and this focus can change. Depending on that focus, you can say that a lens is chosen, which then allows to get or set the focused element, right? Because extract is a bit like a getter. Right, yeah, you're totally right. So that should definitely go into my log. Blog post on setting up this, basically, right? A chronofold is this data structure that came out in this April 27 paper by Viktor Grishenko, who is also the author of RON, for replicated object notation, which has a Haskell implementation here. And the chronofold is a CRDT, but it's optimized for text editing. So it uses the same type of techniques that rope or piece table would use to make text editing really efficient, but it does this on top of a CRDT, so it's at the same time it's real-time syncable. Locus. This lens lets you view the current path of any indexed or comonad, indexed, but that's fine, and seek to a new position. This reduces the API for working with instances to a single lens. Huh. So so you make a lens, locus is a lens, right? Yeah, so you make a lens out of a context. What's the context? Sounds very comonadic. Context AAS. Oh, is it indexed? Is it something for the index comonad? Context. Index store, right? Yeah, it is. Index store can be used to characterize a lens. It is used by clone lens. Yeah, right. So this is the thing I was wondering about. So it's obviously been done. Let's see. I think I was writing some other stuff in an earlier log. Right. Yeah. Here you go. Yeah, because I basically, this comes from the fact that there was this post on Reddit about this new name for the co-state comonad 10 years ago. How cool is that? And someone said something about lenses there. Lens. Not here. I think it was in one of the longer threads, maybe here. Yes. So it could be a selection comonad because type lens AB equal A to co-state BA. And I was like, what? That's amazing. Awesome, awesome. Thank you so much. Really appreciate Chiropsical. Yay, that's me. Awesome. Right, isn't that thing, I mean, I was reading this and my mind was blown like very often, you know, it's these moments, it's like, what? This thing is the same as this thing? So much pleasure being derived from these kind of realizations, but also a lot of, you know, frowning. Like, but how? Right lens over the focus. Yeah, right? That's just the best. Yeah, one, right? There's some traffic today. We have there's people in the house. It's been just you and I for a few streams, but now it's all going. It's a party, a functional party. Amount of data structure you can reduce into free or co-free. Yes. Well, actually, yeah, I started building a much stronger intuition of what free and co-free are. And with like the zapping thing, it's just like, that's my, yeah, that's been very enlightening. Especially using those to do streaming abstraction, right? I was talking about this just a little bit, like the Purescript run streaming. That stuff is like, basically it's like Kmet's machines, or, you know, Gabriel Gonzalez pipes, or even conduits. It's bidirectional streams, but they're written in a free monad. So, and the thing is that it's different from the other implementation that I've seen in Haskell, which is it also wraps the kind of the looping. It's almost like it's deriving like, you know, this is the free structure like next and done, right? But it's using this to do the looping in the stream. And that's just a thing of beauty. Nate, for being honest, so smart. And so that means, to me, that means that you can do some introspection with regards to time in some way, if you're aware of that construction. And I'm quite interested in this idea of being able to reinterpret time, you know, because it feels like it connects, and in the way it connects. So I'm going to go far out here, right? But forgive me for it. Militi, I believe it is. Yes. So you see this crazy signature. Take an A and return in some modal M with some effects in the modal M, a B and the next and the rest. So that's very, that feels very familiar. And it turns out that that's actually, well, it can be used in this kind of bidirectional streaming machinery like it is in data machine. But it's also isomorphic to monadic stream functions as defined in, for instance, Dunai, which apparently has moved somehow. And control monad trans, monadic stream functions. No, I think it's in data. Is it in data? Monadic stream function, yeah. Core. It's internal core, actually, I think. Right. So that's exactly that same. And so this can be used as a proper FRP, completely FRP, basically data type. Or free monad as isomorphic to some co-free monad